Hello, my name is Rhys Pook. I'm a final year PhD student at Newcastle University. This is a reprise of a presentation I delivered earlier this year in the Patey Prize session at the Surgical Research Society conference, titled The Impact of Time to Death in Circulatory Death Donors and Pancreas Islet Isolation Outcomes. So islet transplantation is an effective treatment option for patients with refractory diabetes who experience recurrent hypoglycemic episodes. Islet isolation is a laboratory process in which insulin-producing cell clusters are separated from donor pancreas. They are briefly grown in culture and then transplanted, helping to restore insulin control. As with all organs within the transplant field, improving their supply remains a global issue. And one of the ways we aim to improve utilization is to increase the usage of circulatory death donors. So the donation timeline starts with a possible donor on the ITU. The retrieval team attends the donor hospital, treatments are then withdrawn, and a timer is started. The team then awaits progression to death, where the subsequent retrieval operation starts. The organs are cooled down, removed, placed on ice, and transported to the isolation centre. Between each of these events are physiological time points that have potential to cause injury to the pancreas. We looked at all these periods in our study, but our core focus was the time to death. This, by definition, is the time between the withdrawal of life-sustaining treatment and confirmation of death. And the reason for this focus is that this is the time that dictates the stand-down policy, which is a crucial factor in utilization. So when islets are isolated from a donor pancreas, their quality is assessed using three key parameters: yield, purity, and viability. Yield is reported as islet equivalent units, or IEQs, which standardize islets of spherical diameter. This allows us to compare preparations made up of islets of different sizes and gives a meaningful measure to the total functional islet mass recovered. Purity reflects the proportion of endocrine tissue relative to exocrine tissue, and viability assesses how many of the isolated islets are alive and metabolically active. This is typically measured using a fluorescent dyes which distinguish live cells from dead cells under microscopy. And then each of these parameters has established minimum thresholds, and together they form the NHS release criteria that determine whether an islet preparation is suitable for transplantation. So to assess the time to death's effect on islet isolation, we performed a retrospective population cohort study using the UK Transplant Registry. We included all adult pancreas islet accepted for islet isolation, and we chose the impact of time to death as our primary outcome, as this has not been previously explored in the literature. And this slide shows our group's approach to building the adjusted models. First, we identified potential confounders and then performed multiple imputation to enable us to deal with missing data. Multivariable models using pooled data were then developed to assess the impact of time periods, and we then performed non-linear modelling, which is better suited in some biological scenarios to allow for the precise relationship in our models to be assessed in a continuous way. So in total, we included 153 pancreata utilised for islet isolation, with the median time to death being 14 minutes. The pancreas has a shorter stand-down time compared to other organs, with a maximum time to death of 60 minutes. We assessed the overall islet isolation result, with the median value of all parameters meeting release criteria, and 50.3% of pancreas that were included in our cohort had their islets meet release criteria. So now if we look at the individual scoring metrics of islets, for viability across the full time to death range, it remains stable. Although there is a slight upward trend, there's no statistically significant association between time to death and viability. Importantly, viability remains consistently above the minimum release threshold, shown by the red dashed line. However, there were significant key confounders in pancreatectomy time, cold ischemia time, donor age, and pancreas weight, reinforcing that surgical donor factors dominate over time to death alone. For yield, we see a shallow, non-significant curve, with all the values again comfortably above the clinical release criterion. Once adjusted for confounders, no continuous variables reach significance in adjusted models, suggesting that yield is robust to ischemic timing. Similarly, purity shows no association with time to death. No significant effects were observed for warm ischemia, functional warm ischemia, or cold ischemia time, indicating purity is independent of agonal and retrieval factors. Here we're modelling the adjusted odds of meeting release criteria. An odds ratio of 1 indicates no effect. Increasing time to death changes showed no significance in the likelihood of meeting release criteria, suggesting within these clinically relevant ranges, time-based donor metrics alone don't determine whether an islet preparation is ultimately usable. So now if we focus on two key time points that do show a significant association with islet outcomes, the first is cold ischemia time. We see a nonlinear effect on islet viability. Longer cold ischemia time reduces the likelihood of meeting release criteria, but surprisingly very short cold ischemia can also result in lower viability. The second is pancreatectomy time. Increasing pancreatectomy time is consistently associated with reduced islet viability, with an approximate 1% decrease for every additional 10 minutes. Together, these findings suggest that peri-retrieval and surgical timing exert a greater influence on islet quality than time to death. So our data shows that time to death does not adversely affect islet viability, yield, or purity. Islets appear resilient to agonal ischemia and DCD donation. Instead, post-mortem and procedural factors, especially pancreatectomy time and cold ischemia time, drive islet quality, highlighting a known limitation of the isolation procedure. Importantly, despite being considered lower quality, DCD pancreases in our cohort matched the national UK release rate of 54.7%, which included DBD and DCD pancreas, demonstrating their potential when procedures are carefully managed. So this work, to our knowledge, is the first to explicitly examine donor time to death as a distinct variable in relation to human islet isolation outcomes. We've shown that donor time to death is not associated with negative islet isolation outcomes. And while DCD might be considered a risk factor by some people, we show here that national benchmark outcomes can be reached. However, extended pancreatectomy time consistently reduced viability, underscoring that the quality of islet preparations depends far more on the efficiency and precision of the retrieval and isolation procedures than on donation timings. So I'd like to end by saying thank you to all the supervisors, the Pancreas Advisory Group, and NHSBT Statistics who provide the data, and thank you all for watching.